And yet we discussed up to the range. One question was from Noor K. Sir, what is meant by these ranges? Like what you are want to say that what is meant by these ranges, or what is basically the ranges is covering over here in this course. So beta, like for example, if we have any radioactive material, for example, I'm considering that this is some by radioactive material. Okay, now it's actually emitting some radiation with respect to the time. Um, so the thing is that when you talk about the radiations, like for example, if it's emitting the alpha particles, um, also along with that, it's also emitting the beta particles and the gamma rays. Okay, so एक चीज ध्यान में रखनी है that when we talk about the alpha and beta, we have to call it particles, and the gamma is a ray. Okay, and the gamma ray. Okay, now from the origin, it will from where it's basically originating, जहाँ से produce हो रही है. So alpha will only travel up to 5 centimeter. 5 centimeter will be traveled by the alpha particles. Alpha particles अपने originated region से सिर्फ 5 centimeter move कर सकते हैं. But when you talk about the beta particle, from the originated area, they can travel up to 15 centimeter. Okay, and when you talk about the gamma rays, they can travel up to 10 meters. Okay, 10 meters means it's a very bigger value. Okay, 10 meters जो होते हैं, when we talk about the 10 meters, 1 meter contains 100 centimeters, so it means that we are talking about 1000 centimeters. एक बहुत लंबा एरिया होता है. Okay, so among them, the most traveling, you can say that the emitted particle which can travel more is the gamma particle. Then we have a beta, and then we have an alpha. The reason behind like the approx range is again, it's going to be their weight also. Like when you talk about the mass or the size of the alpha particle, they are bigger in size. So if the particle is bigger in size, so they're going to have a bigger mass. Okay, larger mass hoga because they have a neutrons and a protons. Okay, but when you talk about the gamma particles, they are just an electron. So the electron is going to travel more as compared to the helium nucleus. ठीक है? And जब हम लोग बात करते हैं, when we talk about the gamma particles, it is just an energy. Okay, so energy can travel more. Okay, so that's why अब जब ranges की बात करते हैं, so we have a maximum range for the gamma particles. Okay, now let's talk about the three types of emission. Okay, better. The important thing over here is that you should have to basically memorize the general formulas. So the first one which I ticked in all these three, alpha, beta, and gamma, are the general formulas. अब मैं आप लोगों को सिंपल चीज बताता हूँ. Just look at this. Here, this A is representing the mass number. This Z is representing the atomic number. Okay. जिससे आप लोग मास नंबर जो होता था एटॉमिक मास एंड द लोअर वन जी इज द atomic number. So here I'm writing down that A is mass number or atomic mass number, and your Z is atomic number. Now, actually, beta, whenever any object which goes through the any decay, ठीक है, decay का मतलब होता है वो break down हो रहा है, it's going to some half life. Okay, now whenever any element goes through the half life, and if it loses four mass number and two atomic number, ठीक है ना, so we are going to say that it releases the alpha particle. Okay, and along with that there is going to be energy. Okay, वो साथ energy भी release करेगा. Got it? So इसकी एक एग्जांपल है. There's an example. Just look at this example here. हमारे पास जो lead है, the atomic mass of the lead is 212 and the mass number is 84. So after the decay, the atomic mass of the lead become 208 and the atomic number become 82 because it releases the alpha particle. So the alpha particle release along with that there's a loss of energy. Okay, now let's talk about the beta particle. In a beta particle, there is going to be no change in the atomic mass. Atomic mass is not going to be changed. Okay, so so I'm making a cross in front of the atomic mass, and only your mass number is going to be changed because in the beta particle हम लोग क्या कंसीडर करते हैं that जनरली जब आप बीटा पार्टिकल की बात करते हो उसमें क्या होता है when any element is going to remove the basically if the element is removing the electron, so उसका इफेक्ट आएगा उसके मास एटॉमिक नंबर पे. ठीक है, so that is why अगर आप यहाँ पे देखते हो सो यहाँ पे आपके पास सिर्फ वन एटॉमिक नंबर आपका एड ऑन हो रहा है बिकॉज इट्स रिलीजिंग द बीटा पार्टिकल अलॉन्ग विद द एनर्जी. ओके, इसकी एक सिंपल एग्जांपल है. दिस इज द आइसोटोप ऑफ द कार्बन, कार्बन C14. इट इज एन आइसोटोप. अब हम लोग करते क्या है आइसोटोप ऑफ कार्बन? व्हाट वी डू विद दिस, basically whenever this carbon C14 get attacked by any atom which is having, like for example any atom which is having a one neutron and a one electron, जब भी इसके पास एक इलेक्ट्रॉन आपका न्यूट्रॉन अटैक करता है तो वो बना देता है, इट फॉर्म्स दी नाइट्रोजन, नाइट्रोजन 7. ठीक है, basically the atomic mass of the nitrogen is 14 and the mass number the atomic number of nitrogen is 7, and along with that it's going to release one beta particle. Okay, and the energy. ठीक है, आप लोगों ने सिर्फ ये याद रखना है कि व्हाट इज हैपनिंग ओवर हियर. सो देखिए, आप लोगों का जो अल्फा पार्टिकल्स था ओवर देयर वी वर फ्रॉम द एटॉमिक मास वी वर सब्ट्रैक्टिंग द 4 नंबर. रीजन बिहाइंड इज दैट बिकॉज व्हेन यू चेंज द एटॉमिक नंबर, आपका जब एटॉमिक नंबर चेंज होता है तो उसके साथ ही उसका मास नंबर भी चेंज हो रहा है, क्योंकि पूरा एक अल्फा आपके पास अल्फा पार्टिकल रिमूव हो रहा है, और अल्फा पार्टिकल हीलियम न्यूक्लियस है, तो उसके अंदर 2 न्यूट्रॉन्स हैं, 2 प्रोटॉन्स है. तो जब वो 2 न्यूट्रॉन्स रिलीज हो रहे हैं अलॉन्ग विद दैट वो आपके साथ 2 प्रोटॉन्स भी एब्सॉर्ब कर रहा है, तो उसका एटॉमिक नंबर 2 से कम होगा एंड इट्स मास नंबर इज गोइंग टू डिक्रीज बाय 4. ओके, because when you talk about the atomic mass, आप atomic mass में what you guys considered in the atomic mass, like in atomic mass, in atomic mass or mass number, you guys consider that it is a sum of, it is a sum of neutrons and, just give me a minute, it's a sum of neutrons and protons. Okay, so up, if you're removing 2 neutrons and along with that you are also removing 2 protons, so the mass number is going to decrease by 4 in alpha particle, and the atomic number will be decreased by only 2 because you are removing 2 neutrons. Okay, एक और चीज, when you talk about the atomic number, beta, in the atomic number we basically talk about the number of neutrons. We are not going to talk about the number of electrons. ठीक है, electrons को हम कभी भी atomic number में consider नहीं करते. The reason behind is that an element can easily remove its electron. ठीक है, when you talk about the your proton, आपका प्रोटॉन रिमूव करना एक डिफिकल्ट वर्क होता है. गॉट इट? सो दैट इज व्हाई जब भी हम लोग एटॉमिक नंबर की बात करते हैं वी बेसिकली टॉक अबाउट द प्रोटॉन्स. अच्छा, नाउ लेट्स टॉक अबाउट द बीटा पार्टिकल. Beta particle may we discuss this thing. Just one important thing over here is that in a beta particle, your number, your atomic number is going to be increased by a one number. Okay, क्योंकि we are releasing a beta particle which is going to have an electron. Okay, now let's talk about the gamma particle. Better, generally in the gamma particle there is going to be no change in the atomic mass and the your mass number because it is an energy. और देखो इसीलिए that's why I didn't wrote any energy with this. मैंने यहाँ पे कोई भी energy नहीं लिखी. No energy over here because your gamma particle is, itself is an energy. Okay, so ये ज़हन में रखना है. So just look at over here. Uranium 235 and means atomic mass of uranium is 235 and the mass and the atomic number is 92. When it decayed, it just released the gamma particle. उसने gamma particle release किया without, and there's no change in the atomic mass and the your mass number. Sorry, atomic mass and the atomic number. कोई भी change नहीं आया. Okay, so similarly, आपके रेंडॉन में भी हमने यही किया that when it goes to the decay. So what happened over here? Just there is a release of an energy. Okay, so आप लोगों ने you have to basically memorize the first formula. Okay, and in a paper how which type of question you will get, well, inshallah we will discuss it in future. Mostly what they will do in the paper, like for example, let's take this example. I'm taking this example. They will give you the question like this. Mostly they what they will do, like they will say that we have C14 dash give us nitrogen 14 7 plus the beta particle with 0 and -1 plus energy. So the question is that what would be there in this dash value. Okay, so just you have to write down the value जो आपको लगता है होनी चाहिए. So आपने इसको बैलेंस आउट करना है, सो यू विल गेट द आंसर 6 बिकॉज when you subtract 1 from 7, so you will get the 6. So it means that over there it was a 6. Got it? So you will get a question like this. आपको इससे कोई ट्रिकी क्वेश्चन नहीं देंगे that you have to balance the equation. नहीं, आप लोगों को इसका कि you will get a question like this कि आप लोगों को boxes given होंगे and they will ask that which value or what would be the means what would be the atomic number or the mass number for that specific question or for that specific equation. Other than that, when we talk about the yes, yes,
और क्वेश्चन
yes.
सर, ये अपना फिर पेपर में मतलब ऐसा आ सकता है कि ये अपना पूछें एडिशन सब्ट्रैक्शन करके, और फिर पूछें कि ये अल्फा की डी के इक्वेशन है या बीटा की डी के इक्वेशन है,
नो
ऐसा आ
नो नो
सकता है
नो
क्या
नो
सवाल?
नहीं, देखो आपको आपसे पूछेंगे नहीं बिकॉज दे विल मेंशन आउट द टाइप ऑफ द इक्वेशन. नाउ हियर आई रोट अ बीटा, तो मुझे तो आपको तो पता चल गया दैट्स अ बीटा इक्वेशन. ओके, आपसे इस तरह का क्वेश्चन नहीं पूछा जाता. ओके, अलॉन्ग विद दैट एक और क्वेश्चन होता है, वो बेसिकली इससे भी इतने इंपॉर्टेंट क्वेश्चन नहीं आता. द मोस्ट इंपॉर्टेंट क्वेश्चन बेसिकली आप हम लोग जब वी विल डू दी कंप्लीट डीके इक्वेशन, जब हम लोग चेन रूल करेंगे और दे आप लोगों को मैं तब बताऊंगा. वहां पे होता है दे आस्क दैट हाउ मेनी न्यूट्रॉन्स आर रिमूविंग फ्रॉम द न्यूक्लियस. ओके, एक न्यूक्लियस से कितने अमाउंट ऑफ न्यूट्रॉन्स रिलीज हो रहे हैं और इमिट कर रहे हैं. तो वो हम लोग आगे देखेंगे, वो उससे रिलेटेड मैंने क्वेश्चन भी रखे हुए हैं. ठीक है. So now, acha, beta, do you guys remember in the last lecture, I said that when you talk about the deflection of the alpha, beta, and gamma particles in the electric field में जब हम बात कर रहे थे, so at that time I said that when you talk about the alpha particles, as the alpha particles are a positive one, so they move to the negative plate और the Fleming left hand rule apply होगा. Fleming left hand rule किस कब apply होगा? This rule is going to apply for your magnetic field. Okay, so I'm also explaining the deflection of electric field. Along with that, I'm also explaining the deflection for the magnetic field. So this is the for deflection of magnetic field. अब ये मैं इसलिए आप लोगों को explain कर रहा हूँ because मैं आगे इस चीज को clear भी कर रहा हूँ. ठीक है. Similarly, for beta, beta is a negative charge. So it's when you are going to introduce it into the electric field, so negative charge will move to the positive field. Okay, and again it will follow the Fleming left-hand rule in the magnetic field. Okay, now just look at this diagram over here. Now just look at this electric field diagram first. So सबसे पहले we are going to talk about this diagram. Okay, बेटा देखिए यहाँ पे we have some particle over here at the bottom. यहाँ पे एक particle था which is actually emitting the alpha, beta, and gamma particles. Now just look at over here. As I told you earlier that the beta is a negative charge, so वो positive plate की तरफ जाएगा. Now just look at this. This beta is moving to the positive charge. The gamma will not move or will not deflect. The reason behind is that because it has no charge. While when you talk about the alpha particle, alpha will move to the negative charge. Now one more important thing. Beta, as you guys can see over here, the deflection of beta is more as compared to the deflection of alpha. The reason behind is that this alpha particle is heavier and the beta particle is lighter. So if the element is going to be heavier, so it will take a lot of time to get deflected. Simple example is that like boys can relate
सर
this. Right? Yes, yes.
सर एक बार और रिपीट कर दें.
Okay. So here now in this example, what I explained to you guys that here this is some radioactive element which is emitting alpha, beta, and gamma radiation. So the alpha will basically deflect towards the negative plate. Your beta is going to deflect towards the positive plate, and the gamma will not deflect it because it has no charge. Okay. Why alpha is deflected to the negative plate? Because the alpha is having a positive charge. Okay. The beta is deflecting to the positive charge because the beta is having a negative charge. Okay. Now, the third important thing is that why the angle of deflection of beta is more as compared to the angle of deflection of alpha. The reason behind is that your alpha particles are heavier, they are very heavier as compared to the beta particles. Okay? So beta particles are lighter in their weight, so that is why they will deflect it easily as compared to the alpha particles. Now the thing is that a boy can relate this thing very easily. Like for example, when you go from any highway or any road, आप लोगों ने नोट किया होगा that whenever the heavy vehicle like a bus or a container or a trailer, they are taking a sharp turn, so they are not able to take a sharp turn. ठीक है, they have to cover a lot of an area. ठीक है, like for example, if this is a road, okay, now over here I'm just trying to make a proper road. Okay, so आपके पास ये एक road है, just give me a minute. Okay, अब बेटा just look at over here, we have a bigger trailer. ठीक है, एक हमारे पास bigger trailer है. Okay, and along with this bigger trailer हमारे पास एक साइड पे एक small car भी है. Oh, here there is a small car. You guys know it very well that a car can take a very sharp turn over here. ठीक है, because उसका weight कम है, it can easily take a sharp turn. But when you talk about a trailer, it has to take a very long turn. The reason behind again is that it has a larger weight. तो जो चीज का weight ज्यादा होता है उसका angle of deflection जो होता है वो smaller होता है. Got it? So ये एक simple example थी. That's a very simple example for your understanding that why the beta particle is taking a very sharp turn, or why the angle of deflection for the beta particle is very greater, because the beta particle is lighter in weight. Okay, so I'm just removing this diagram now. Okay, या चलें ये रहे.
सर ये अपना वेट से मुराद मतलब वो अपना उसका मास जो होता है एटम का, अपना प्रोटॉन और न्यूट्रॉन का.
Yes.
अच्छा अच्छा, तो अल्फा का प्रोटॉन न्यूट्रॉन ज्यादा है बीटा पार्टिकल से.
क्यों बेटा, क्यों नहीं होगा? Just look at your alpha particle. In your alpha particle, you have a four atomic mass, and two is its atomic number. Means when you talk about the alpha particle has two neutrons and two protons. While when you talk about the beta particle, it has no mass number, but it has only one charge, or a one, you can say that one electron. It's going to have only one electron. Okay, तो
उसका
आप मुझे
मास नंबर
बताओ
नहीं है
क्या,
इसलिए वो जल्दी डिफ्लेक्ट हो रहा है.
यस आप मुझे बताओ, इलेक्ट्रॉन
अच्छा सही.
इलेक्ट्रॉन लाइटेड है कि एक प्रोटॉन और न्यूट्रॉन का मिक्सचर लाइटर होगा?
क्या क्या चीज?
द क्वेश्चन इज दैट मूसा, कि आप मुझे बताओ कि क्या एक इलेक्ट्रॉन लाइटर होगा या एक ऐसा एलिमेंट जिसके अंदर न्यूट्रॉन एंड प्रोटॉन है?
इलेक्ट्रॉन इलेक्ट्रॉन लाइटर होगा, इलेक्ट्रॉन हल्का होगा.
इलेक्ट्रॉन, या यस, आप लोगों को याद भी होगा that आप लोगों ने केमिस्ट्री में पढ़ा भी होगा that the mass of the electron is 9.1 times 10 to the power minus 31 kilogram.
यस यस.
ठीक है, सो वो कितना लाइटर है? It is
हाँ.
approximately, if I'm not wrong, I think so, it's 30 times lighter than the neutron, अगर मैं गलत नहीं हूँ. As I'm not a teacher of chemistry, so आप सर नुशाद से प्लीज कंफर्म कर लेना. Okay, now let's talk about the magnetic field. Okay,
अभी वो 10:40 हो गए ना, तो ब्रेक है ना अपनी.
okay.
11 बजे हम आते हैं इंशाल्लाह दोबारा.
Okay, चलिए सही है. Okay, students, let's talk about the magnetic field. For a magnetic field, आप लोगों ने क्या करना है? Don't forget that you have to follow the rules of the flaming left hand rule. When you talk about the flaming left hand rule, this is your thumb, your first finger, and then you have the middle finger. So the thumb is basically, and don't forget the statement that is FBI. Okay, you have to keep this in your mind that we have to go with the FBI. This is your F. This finger is representing your B, and this middle finger is representing your I. F means force, B means magnetic field, and the I means the current. अब मेरा बच्चा होता क्या है? Just look at over here. In the magnetic field, we are considering that the direction of the current over here is from. Give me a minute, so I look it up. Okay, so the direction of the current is from left to right. Okay, left से right की, sorry, direction of current कह रहा हूँ. The direction of the radiation is from left to right. Radiation जो है वो आपकी left से right पे move करेगी. अब होता ये है. Give me a minute. Put off a pen. Now, अब सबसे पहले वी आर गोइंग टू यूज फ्लेमिंग लेफ्ट हैंड रूल. अब उससे पहले बेस्ट ऑप्शन ये है कि वी हैव टू क्लियर दिस थिंग्स, राइट? व्हेन यू टॉक अबाउट द बीटा, your beta is actually electron, and the direction of the electron is opposite to the direction of the current. So it's going to be opposite to the direction of current. Means if the electron is moving to the right, so the current is going to move to the left. ठीक है? अब ये ज़हन में रखो, और दूसरी चीज ये ज़हन में रखो that your beta is a negative charge. and your alpha is basically a positive charge. Okay, it's a positive charge which is basically having two protons. इसके पास two protons है. Beta के पास over here it has a -1 electron over here. So just I want it to make more proper, so it's a 0 and it is 4. So आपको ये चार्ज ध्यान में रखने हैं कि आपके पास ये चार्जेस कैसे होते हैं. अब जस्ट इस तरीके से इलेक्ट्रॉन जो है, इलेक्ट्रॉन एंड आपका जो बीटा है, दे आर सेम, सो इट मींस दैट द डायरेक्शन ऑफ द इलेक्ट्रॉन एंड द बीटा आर गोइंग टू बी सेम, while the direction of the beta and the alpha is opposite to one another. So yes, it means that our alpha is actually acting like a current. Okay, उसकी डायरेक्शन करंट की तरह होगी और बीटा जो होगा उसकी डायरेक्शन इलेक्ट्रॉन की तरह होगी. नाउ this is your F, this is your B, and this is your I. First of all, point out your B into the page, because over here the cross is showing that the magnetic field is into the page. So I just identified my finger towards the direction of the magnetic field. I mean, this field की तरफ कर दिया. Now my this finger is indicating the direction of a current. Okay, so for the alpha, the direction of the current is from left to right, क्योंकि आपने ये कहा है कि हमारे पास रेडिएशन इस तरीके से मूव करी है. ठीक है, सो हमने अभी अभी यही बात हमने डिस्कस की थी, दैट योर अल्फा इज बेसिकली बिहेव लाइक द करंट. ठीक है, सो अब यहाँ पे डायरेक्शन ये है. अगर मैं करंट की बात करूँ तो डायरेक्शन ऑफ द करंट इज राइट, बट यू टॉक अबाउट द इलेक्ट्रॉन्स, फॉर दिस कंडीशन तो इलेक्ट्रॉन की डायरेक्शन होगी ऑपोजिट. ठीक है, सो this is into the page, direction of the current, and now the thumb. The thumb is representing the direction of the force. So it means that the alpha particle will move upward. Okay. Now I'm just basically I'm just adjusting my middle finger with respect to the direction of the electron or a beta. So मैंने इसको reverse कर दिया. अब देखिए मेरा बच्चा, मेरा जो thumb है downward direction शो कर रहा है. It means that the beta has to move in a downward direction. अब आप लोगों ने ये ध्यान में रखना है that the alpha is going to the angle of deflection for the alpha is lesser as compared to the angle of deflection for the beta, क्योंकि ये बात हम पहले डिस्कस कर चुके हैं. Reason behind is again the same, that the beta is lighter and the alpha is heavier. Okay, जो heavier होता है वो ज्यादा टाइम लेता है to basically to change its direction, तो deflection में टाइम लेगा. While when you talk about the gamma will not change its direction because it is a chargeless. ठीक है, no charge है. ठीक है, so it has no charge, तो ये अपनी डायरेक्शन नहीं चेंज करेगा. गॉट इट. एंड अल्फा की डिफ्लेक्शन ज्यादा होगी, बीटा की डिफ्लेक्शन मतलब एंड ज्यादा टाइम में अल्फा डिफ्लेक्ट करेगा एंड बीटा लेसर टाइम में डिफ्लेक्ट करेगा. ओके, so this is the end of this topic, inshallah, and further we will talk about this chapter in the next class.